Good afternoon, everybody. My name is Suhaib Alfageeh, and thank you for coming. My presentation today is called Hacking with Love, because I'll be going into reverse engineering of everybody's favorite dating application, Tinder. I'm going to go into some of the tools that I use to reverse engineer the app. I'm going to go into a little bit about what it means to reverse engineer an app and what it all looks like at the end and what you can do with it. Unfortunately, resolution here. Can everybody see just fine? Great. So, a little bit about me. I am a software engineer at Veracode. I work on software scanning applications, specifically around mobile. I've been working at Veracode for a few months now, coming up to 4, but before that I was just a front-end developer. But on the side I tinkered a lot with Objective-C, Swift, iOS in general, jailbreaking an iPhone, the runtime, and basically how to hack an application. So let's say you have curiosity, you have a question about an application, you want to know a little bit about how a certain feature works, or about a bug, why it exists, why it's there, how to fix it. A lot of times you look into the source code, but let's say you didn't have the code in front of you. In most cases, the app doesn't belong to us. Let's say an app like Tinder, for example. The only way that you could really have access to such an app is just by downloading it over the net and putting it on your computer, and what you're left with is an IPA file. But if you're not able to look at the source code, how can you kind of take a look at an application, learn about its behavior, and kind of understand what it's about, what goes on behind the scenes? Well, an IPA is an iPhone application, and much like a zip file, it contains a directory, it contains images, assets, bundles of information that you could use to identify the application in a property list file, and information about the signature of the application. So it has the binary. What is the binary? The binary is the actual program that compiled down to the instruction set that the architecture on the device will understand and allow the app to behave, perform. So if you want to understand an application, it all starts with something simple, right? A question. How does something work? Why does this happen? What happens when I do this? Where does information go whenever I sign into something, whenever I perform an action? All of these things, in developer speak, they are, what functions are called, what methods run behind the scenes, what API endpoints are there. So to dig deeper, you wonder why an app crashes. You want to know how a certain feature is designed, what frameworks are used to build it, what assets are used, if it's using images or not, if it's reactive or not. You can take a look at these applications behind the scenes only if you have the source code or if you're able to actually decrypt the application. When you download an application from the App Store, Apple encrypts it with something called Fair Play encryption. And so Fair Play, doesn't really give us the ability to extract any useful information out of it. But a lot of tools over the past few years have been created in order to allow us to decrypt these applications, to extract header information about the classes, the properties within the application, and overall try to allow you to get a better understanding of what goes on behind the scene. It's kind of like a blueprint. So there are 4 steps to when you're trying to reverse engineer an application. 4 basic steps could be divided into what you see on the screen in terms of decrypting the application. You have to get the blueprint, study and understand it, and then once you understand it, you get to modify it and optimize it the way you want. Either create a new feature, change the way an existing feature works, so on and so forth. So why did I pick Tinder? Besides the fact that, most of us have at least heard about it, a lot of us here probably tried the app. It's easy, it's fun. You swipe left, swipe right, and it doesn't get any easier than that. Why I picked Tinder as a subject to study is because you get a wide range of different sorts of people, different reasons people use it for. Some people use it just for fun. They like to just swipe left and right without any interest in meeting somebody. Some people are genuinely looking for love. Some people are looking for a friend. Other people are just looking to advertise or just to get their Instagram profile out. And of course, many of you all heard of probably bots that are used to kind of scam people, solicit money, so on and so forth. So a lot of the different things that you can do when taking apart an application like Tinder and understanding it is to kind of understand the differences between each profile, the differences between each user, the differences between what they choose to put on their profile or not. This kind of information allows us to either optimize our search for somebody, for instance, or kind of identify which one is a bot, which one isn't. This is something, of course, the company already took care of with a third-party vendor that allowed them to kind of go through their database and eliminate any fake profiles that were being used. But again, to reiterate, we all understand this app. We all have at least heard of it. And it's something that, throughout this presentation, something that might seem very complex can actually be very easy to understand. The first tool I'd like to show you is called Flex. Flex is created by a company called Flipboard. It created the Flipboard magazine app that, if anyone has ever used an iPad, may have tried it at least once, or on their iPhone as well. What Flex allows us to do is to actually do live introspection of an iPhone application. It allows us to kind of inspect each object on the interface and the objects in memory. It allows us to kind of understand the different properties at runtime and kind of see what's going on behind the scenes, because a lot of things aren't there when you're doing a simple static analysis. Static analysis only gives us what's constant, what's not changed. But what about what happens when you do sign in? What sort of information is recorded about you? What sort of information is sent about you? What's shared to advertisers, so on and so forth. So this allows us to kind of go behind the scenes while we're using the application. But let's say I just wanted to study the application's blueprint, the application's the API. Another tool I'd like to point you to is also called Flex by developer John Coates. And what Flex is, it allows you people to create patches for their apps. But if you're a developer, you get much more than that. It gives you an easy way to kind of decrypt the binary and extract the header and class information. Not only that, but it allows you to kind of do a quick kind of prototype. It allows you to patch an app immediately and kind of see the way it affects the app before you actually go in and write code and inject the custom code into the application. Let's say I wanted to modify an existing feature inside Tinder. What most of us do by practice is, using English, put descriptive symbols for when we want to, label a method or, a class name. So let's say, for example, if I want to find out whether or not someone has used the app recently, just by looking into the code, even though that's no longer a feature in the app, I can find out that it still actually exists in the code itself. So if I do a search for something like last active, I get to look through any method inside the application with last active inside. If you take a close look at the top cell, the method in the app delegate should show last active on normal profiles. Right now, if you turn on the application and you try and use it, you'll see nowhere in the app that it shows us any last active information on the user. But let's say I wanted to always constantly return true for this Boolean function. Using Flex, I'm able to quickly kind of test that out. I'm able to select this cell here. I'm able to tell it that I want it to always return true for that method anytime it runs. And so I turn on that patch and I'm able to open the application. I'm able to try it out for myself. And using a combination of different methods here and kind of injecting my own definition on my own return value, I'm able to find out just how these different on and off switches affect the application overall. So by combining a number of these, I'm able to create a feature or a combination of features. Using the same method here, by searching through the class names and the method names, I'm able to find out whether or not the like button is really just, whether or not I could actually use the like button and have it repeat itself over and over and over again, for instance. That's another way that you could take an existing API and modify it to create a new feature, such as an auto-swipe feature, for example. But more on that later. Another tool that I'd like to point you to is called Frida. And unfortunately, when we're studying an app statically, or even if we're studying it dynamically, when we perform an action, we kind of see very little about what goes on behind the scenes. We're only able to see the effect on the screen, or maybe we can even intercept the network call and see what endpoint it reaches and what's sent over to the Tinder server. But what if there was a better way to look at it? What if I was able to instrument the application and actually trace the function calls of the application? That I can see that if I tap something, or if I swipe, or if I log in, or if I log out, I can see all the methods and functions that are called by calling that individual method. So with Frida, you can automate a lot of different actions and kind of get results from that, and then analyze those results, for example, for studying. But let's say for a curious mind, you're going to be doing a lot of this manually. You're going to be, connecting your device to the computer. You're going to be typing in what you want to look for, and then you're just going to look at a screen and basically try and understand what happened. So here, for example, I'd like to trace anything in the Tinder regex class, basically any class with that prefix. And I want to be able to trace any function containing the word like inside of it. So what does this get me? It allows me to trace 5 functions. Like stamp view, like button tapped, like stamp, and something related to the paywall, which, if you all know, Tinder monetize and you're able to pay for different features. So what I did here was I ran the application and I wanted to trace any function that had the word like in it. So I can see that if I press that, does it also call anything else out that if I wanted to intercept and then modify there. The reason we do this, the reason we want to see what functions are also called from a single call, is because we want to know that if we want to inject custom code into a certain part of the application, we want to know where and when it's affected and what sequence these functions are called in order to know what can be, in order to know where to inject your code. And finally, when you're studying an application, you want to know the network requests that are being made. The last tool that I've used to be able to hack this app was MITM proxy. You could use any sort of HTTP proxy application to be able to kind of look at the network calls behind the scenes. This one I use because it's pretty easy to use. It lives in the terminal, and it works actually really well. This lets me inspect and modify all the network calls that go on. So this is one that I did of a Tinder like call. So what this gives me is both the request, the response, and some more details about the call itself. So why would I want to know whether or not this happens behind the scenes? I want to know that if I'm creating this feature that, for instance, automates the like button over and over and over, is it actually being registered? Is it being accepted as a like on Tinder servers? Or am I just removing any profile that shows up on screen and does nothing for me? Well, studying this gives us information on the API. It allows me to know how the API, what the API looks like. How, if I want to use something like, if I wanted to use a curl request and kind of do something similar on my computer to kind of study the response and study the, study the response of the application, of the API call. I thought this part of the presentation would be most interesting if I were able to demo all of this live in front of you guys. I want to take the chance right now to kind of show you guys everything I just did on the screen and allow you to ask questions, allow you to speculate on some of the features of the app itself. And we're going to go in, take a look at them, and see how we can create a new feature, for example. If you'll give me a moment, I'm just going to turn on my device here. So I've just opened the Tinder application and launched the Flex tool that I showed you before. What this is going to give us the chance to do is to actually inspect the runtime and kind of see the classes that are actually active and the ones that are being used inside the app at the moment. So here we can search through the application and see that there's a live instance of the app delegate. The kind of information this gives us is only relevant to a developer who wants to change any of the basic settings of the application. But we already saw before that one of the settings that we could change was last active, for instance. So if we go in here and we type in last active, we'll know that we've already changed this to 1. But of course you can simply do this to any class in the application and actually execute the methods live and see how they affect the app. Before I continue with the demo, I just want to take a moment to hear any of your questions. I know some of this we may have kind of swept through this.
One quick question. Difference in accessibility for Objective-C versus Swift applications?
It depends on the tool. If you're using Flex, the standalone application that lets you statically look through, it works on both Objective-C and Swift. This tool here, Flex by Flipboard, it has very limited support for Swift applications, but it does allow you to actually inspect any app, whether it's written in Objective-C or Swift, even though some of the symbols would be obfuscated. Please go ahead.
Do you need root access to install any of these applications? Do you need Cydia installed?
To do many different things that I've shown you now, the environment you need is a jailbroken device. And being jailbreaking a device right now is supported up to 10.2. But a lot of the tools that I've also shown you include the source code, which allows you to test these on your own applications without having to have a jailbroken device. You just include the source code into your project, and you're able to run instances such as Flex by John Coase and this one by Flipboard onto your own application and study that. So it's not just about reverse engineering. This gives you debugging powers. This lets you solve almost any application in a fraction of the time that it really would have taken you to do without these tools. Why? Because it kind of gives you on one screen everything, all the debugging information that you need about the app. For instance, if I'm open an application like Uber and the map is failing to load and I don't understand why, I would simply trace the network call to see that it's either the token expired or I need to re-sign in or something like that. And that applies to any application that we're using. Sorry, I want to take another question. Someone had their hands up.
I did, but you answered it.
I did.
I just want to make sure that this was on a jailbroken device. I was wondering how you were actually getting that to work, but that makes sense.
Let me see. Now, in most of these presentations, you guys don't want to just stare at code, but if I were to show you one project that I've worked on, I'm able to actually, it doesn't fit on the screen right now. I can show you that later, but I want to do another exercise of how I can use these tools to inspect the property of an element inside the application and change its behavior for results that can actually be useful to somebody. For instance, we all know that one of the, how many people, show of hands, how many people here have used Tinder before? If you've used it before, you know that there's a 4-year span between the people that you can actually search for. There's a span of 4 years. Let's say you wanted to look for somebody more your age. Let's say you want to search somebody, 25, 26, whatever it is your age is. So using this tool, I can simply select right here and kind of inspect this part of the application. The class name for this element is Tinder slider. So once we select it with this tool and then we select views, I can go into the properties of this slider and understand how it works. One of the properties is, minimum span. The minimum span here in English tells you that there's a span of a certain number, 4 years usually. But what if I changed it to 0.5? Why 0.5? 0.5, when rounded to 1 by the application, allows me to keep both ends of the slider and, to keep both ends of the slider and narrow it down to 1 page. So I can take this and move it up to 24. And saving that will just load only profiles of people with the age of 24. Let's say I wanted to take the like button and I wanted to be able to automate that. I would start a timer that checks every second or every swipe whether or not there's still cards on the screen. And you can inject your own code. Let's say I wanted to shake the device and I wanted to have it just swipe for me. What this So what did I just do? So what I did was I looked through the classes of the application and found out that in Tinder recommendation view controller, there is a tap like button method. And by starting a timer, like I said before, that checks that there's still cards on the deck, I can just have that repeat every custom interval that I want. And to make sure that it worked, I used MITM proxy to check that every single like returned a 200 code, and that it told me that this was a like that was accepted by the server, which showed me that the feature that I was creating actually worked, and it wasn't just a cosmetic feature. So what can this information do for us, knowing about how the app works? Let's say I wanted to be able to gauge how a certain conversation is going with somebody that I've been talking to for a while. I can take every single message inside the conversation, for instance, and send it to an API like IBM Watson's Context API, which can give me a score of the tone of the sentence or the string. And using a combination, using an average of all these scores, I can say, oh, okay, this conversation is going really well, or this conversation isn't, or perhaps I was being a jerk when I said that. Other things that we can do is kind of study how often, people respond. How often people respond, because every message that's being sent is tagged with a timestamp. These kind of things allows us to score overall, the conversation. But when I first worked on this, it had nothing to do with tone of the conversation, it had nothing to do with the age of the people that I wanted to see. It was actually because when I first used Tinder, I was in a small college town. So I was in a small place around 20,000 college students, which meant the likelihood of interacting with a real person was very high. When I moved to this city, it turned out there were a lot of bots. There's a lot of people asking for money, a lot of people with fake profiles. But I noticed something. That there was something common with all these profiles. They either had no bio, they either responded as soon as you matched with them, or they had 1 or 2 pictures, and sometimes they weren't the same person. So what I did was I was able to intercept the updates response, which gave me all the recommendations that came back from Tinder. I was able to take all those photos and send it to Clarify's API. And what Clarify does is it analyzes an image and it gives you back different either metrics of the face, or it gives you back the objects inside the image. So I was able to take every single profile picture and compare it against each other to validate whether or not those were the same person in every single image. I could check the Tinder user class to check whether or not that user was created, just a few days ago, whether or not they were created with a profile, with a Facebook profile that existed longer than a month. And, tying all these up, you can put together an algorithm that gives you a score on whether or not it's a legitimate profile. So these are just some of the different ways you can use the data that's already in the application to optimize the experience. Does anybody have any questions so far? Great. Yeah.
So has your algorithm worked?
It did, but when Tinder used this vendor to kind of sweep through their database to remove bots, it was no longer something that was easy to actually test carefully. But what it did was it landed me, an interview with a company that actually used iOS or mobile products to kind of test the validity of a government-issued ID. And by showing them some of the work I did for this, they quickly understood that using these tools or a combination of these tools and just having that out-of-the-box thinking of taking an end product and disassembling it was something fit for somebody in security. And so it just shows that you can do a lot of different things. You could either help yourself meet somebody, or you could keep yourself away from potential creeps, or you can kind of gauge the way you are when you talk to somebody online. I would like to give you one last demo before we go. I apologize. Due to the screen resolution, this wouldn't be something effective enough for the crowd. But I just want to end this talk by saying all these applications carry lots and lots of data. Lots of data that's usually only privy to the people on the other side, like the advertisers and the owners of the application. But we can use the same data to our own advantage to take any application and change it in a way that will benefit us as the user. I can do a lot of the same things that I did here to check whether or not surge pricing on Uber suddenly went out, or when it'll go out, or try and either study the different changes in prices and the fluctuation, for example, to kind of know when's the best time to travel, when's the cheapest or most expensive times of the day. These kind of tools can be used to debug your own applications and to understand how to fix things in your application that you weren't able to kind of use with the built-in tools inside Xcode. And finally, if you're just a curious mind and you want to learn how a program works, you can take it apart and just study it if you're working on your own application. Reverse engineering has reasons in security, but also just for a developer looking to learn. Thank you.